Hello again. So now we're going to be talking about linear and exponential word problems. Once again, we're going to just really move through this fast. Linear equations have the form y is equal to mx plus b. You're adding something every time. The graph is a straight line. An exponential equation has the form y is equal to a times b to the power of x, where you're multiplying by something every time, and the graph is curved, it's growing really fast or decaying really fast. In this self-check, or in this video, we're going to be talking about reading a word problem and deciding if it's linear or exponential, and then writing an equation for it. So it's really similar to the one about tables. We just now put it in words instead of tables. Let's start with the first example. The first example says Maddie has 200 cookies and eats 3 per day. So the first thing we have to decide if it's linear or exponential. The way that we're going to do that is with a couple of clues about words. So if I said doubles, triples, halved, quadruples, cuts in third, that's a really good sign that it's exponential, because what that's telling me, it's like if it says it's doubling, that means it's multiplying by 2. If it's tripling, it's multiplying by 3. If it's halving, it's multiplying by 1/2. Now, if it doesn't say those things, it's a pretty good thought that it is a linear function. So in this one, on number 1, it doesn't necessarily have any like doubling, tripling. So I'm going to assume that it's linear. Let me put my marker on blue. And when it's linear, we know that the formula is y is equal to mx plus b. And we actually already have this information too. So my m is the slope, or what's changing every time, okay? And then your b is your y-intercept, but that's also the way that you want to think about it in this case is like your starting amount, okay? So I know automatically that my b has to be 200 because I started with 200 cookies, or Maddie started with 200 cookies. And then our slope, or the thing that's changing, is how many does she eat per day? Well, she eats 3 cookies per day, which means that it's taking away 3 cookies from our starting value. So instead of putting just 3x, what I'm going to do is say minus 3x. The reason why I put negative 3x on there is because I'm losing 3 cookies a day. I'm eating 3 cookies a day, which means I have less cookies every day. But this is our equation, our linear equation, to represent the word problem. Okay, now let's look at the second question. It says a new car is worth $10,000, but the price depreciates by half each year. So it's telling you that 1/2, or it's halving each year, which automatically tells me that it's an exponential equation. And because I know it's exponential, I know it has that formula, y is equal to a times b to the power of x. And this is really similar to the linear function in that you already have the information. Your a, in this case, is like your starting value, and then the b is what's changing every time. So the starting value of the car is $10,000, which means I'm going to say y is equal to 10,000. And then our b is what's changing every time. Well, it's depreciating by 1/2, or it's multiplying by 1/2 is another way to say it. And so that b is 1/2 to the power of x. And this is the exponential equation to represent the function, or the word problem. All right. So those are 2 different examples of like one's linear, one's exponential. But let's go through a couple more. So the next one says 550 squirrels live in the park. The population triples each year. So this word triples is a really good example for when it's exponential. And because that triples means that it's multiplying by 3 each time, right? I'm going to just put a times 3 right there to remind us. Because it's an exponential equation, I can say that it's y is equal to a times b to the power of x, where remember, a is your starting value. So how many squirrels did we start with? Well, we started with 550, so that's my starting value. And then my b is what's changing every time, or what we're multiplying by every time. Because it says that we're tripling, we're multiplying by 3, so my b is 3. And then we're going to take it to the power of x to finish off that exponential equation. All right, and that last example says Sean goes to the grocery store with $100 to buy apples. Each apple costs $2. So this one doesn't have anything about halves or triples, quadruples. So we're going to assume that it's linear. And a linear function is y is equal to mx plus b. And where m is what's changing every time, then b is what you start with. And so Sean started with $100, so we know it's going to be y is equal to something times x plus 100, because that's our starting value. Now, each apple costs $2. Once again, this is That's what's changing the $2. So this can be a 2x, but it's not just going to be 2x, it's going to be negative 2x. The reason why it's negative 2x is because every time I buy an apple, I lose $2, or I give $2 away, which means I have less money. And so that slope, or what's changing, has to be negative instead of positive. And here is our linear equation to represent the word problem. And there we have it, linear and exponential word problems.